When you do segmenting, you start with an image, and that image is then made into the components of the image that you wish to measure, done by thresholding, and then go into a measurement program, and in this instance, ImageJ, to measure area, length, counts, etc. And you'd like to do it in such a way that features don't touch, which isn't always possible. And you don't want to include partial features. So the object of segmenting is to consistently set filter and function settings so that objectivity can be maintained, especially the threshold value. Note that it's not always possible because of specimen to specimen differences. See the video on unbiased sampling for more information at my website, jerrysedgewick.com. When you do measurements, generally you're looking at two measurements. The measurements of the objects of interest, those things that are positively labeled, and then the tissue area that the objects of interest sit on. So that would be the background tissue. Generally, measurements are the objects per surface area of tissue. And of course, there are some exceptions. So here you have an image, and then from that image you have the thresholded area that you wish to measure, and then that's sitting on a reference area that you would want to create so that you can eliminate any holes that are in your tissue. Note that when you're doing computer-aided image analysis, use the lowest magnification in which features can be positively identified. Image features should comprise 8 pixels or more so that you're sure to have enough pixels to actually get decent measurements. Highly compressed JPEG images shouldn't be used when segmenting because of compression artifacts. Images from microscope slides need to have features also that are in focus. Out of focus features often contain parts of the image that are difficult to identify. So to solve that problem, you can make thin slices, or with the confocal use a projection from image stacks. As an example of what an image might look like were you to use an image with out of focus parts, I can zoom in to this image, and you can see that there are out of focus and blurred parts of this image that you could potentially count, but would be difficult to identify as positively labeled complete cells. If I were to use a function in Photoshop called focus area, I could also see how much of this image is actually in focus. You can see that very few of these cells are actually in focus. If more than one color exists in an image, such as a color bright field image, you can split the channels to find the channel that has the greatest contrast and a channel that might show the tissue area without features of interest looking like they have a great degree more contrast than the background tissue. Here I have a color image. The first thing I need to do is split the channels so that I can find areas of highest contrast. So in the channels palette, I'll choose split channels, and then from those channels I can see that the blue channel is very low in contrast. I'm not going to select that. But the green channel shows the holes very well, along with the features of interest. The red channel, which shows the features of interest very well against a rather light background. If brightness and contrast differs among images, you can use the match color function in Photoshop to match the contrast and brightness of all grayscale images. In ImageJ, there's a function called normalize under enhanced contrast that does a fairly good job of the same thing. Or you can use a bandpass filter in ImageJ before using fine maxima if you're doing counts or if you're taking other measurements. That filter in Photoshop is called high pass. This is a powerful tool for segmenting smaller objects, and it's part of the Sedgewick method for segmenting. And it's used in the following publication among many others in which I've used it. You can see here that we have two images that are different in brightness. I prefer this image here to be the target image, but first of all, I'm going to make sure that both images are set as RGB color, even though they're in grayscale. Otherwise, this function won't work. Under Image Adjustments, I simply go down to Match Color, and then down here in Source, choose the other image. And now the two images match. Under Filter, Other, High Pass, I'm going to set a high pass radius. How I set that radius depends upon the length of each one of these particles. So to start off with, I'm going to go to the eyedropper tool, choose the ruler tool, and then measure the distance of one of these particles, the largest particle. And then over in my info box, I'm going to see what that length is. And it shows that it's 120. So under Filter, High Pass, I'm going to set the radius. I'm just going to set it at 100 and say OK. So when you segment, those steps involve starting with a representative image, often the best image from a session to show results. And the methods that are used iteratively. You start with trial settings, then fine-tune until segmenting is ideal. So you have to go back and forth with your settings to determine what works best. Nearly every image can be segmented if uneven illumination can be corrected. Here I have a color image. The first thing I need to do is split the channels so that I can find areas of highest contrast. So in the channels palette, I'll choose split channels. And then from those channels, I can see that the blue channel is very low in contrast. I'm not going to select that. But the green channel shows the holes very well, along with the features of interest. And so I'm going to copy and paste this on the red channel, which shows the features of interest very well against a rather light background. So I can select all. And then using my keyboard, I'll use Command, Control, plus copy, C, and then on my other image, Command, Control, plus V, paste. Now that I have my layers here, I can outline the part of the layer that I'm interested in. I can either use the polygonal lasso tool and work my way along in this manner, or I can use another tool, and this is called the Quick Selection tool. Using that tool, I can set in the submenu the size and the hardness to 100%, and then move my way along to then outline the area that I'm interested in. I'm going to include a little bit here, but I can see here this is a hole, and so if I click on the Alt Option key, I can move my way along this top area to then only select the area that I'm interested in. Once I have that area, I'd like to select the inverse of that area under Select Inverse, and then under Edit, fill that area with white. And if I'm in my Layers palette down here, I can then click the eye icon, choose the background layer, and also fill that layer with white. I'll deselect and then start with thresholding this layer. If I go to the eyedropper tool and choose the ruler tool, I can basically figure out the length of one of the features, a longer feature, and I see that that length is approximately 40. So under Filter, Other, High Pass, I'll put 40 in. And then under Image Adjustments, Threshold, I'll threshold this image until all I see are my features of interest. If I choose the layer above that one, this is my tissue area layer. And for this, because it's such a large field, I don't choose a high-pass filter. Instead, I simply use my threshold tool to then include everything on this image but the holes. Note that this image is evenly illuminated, and so this is no problem when I use the threshold tool. If it were unevenly illuminated, I would have to correct for uneven illumination before I did the thresholding. I can now save one layer as a TIFF file or a PNG, and then save the other layer as a TIFF file or PNG. As an example of how the high-pass filter works, you can see that there are particles in this 100 millimeter Petri dish. These particles came from a capture device that collects emboli after a stent is put in. I used part of this image and then made it into a grayscale. First of all, I'm going to go to the layers palette and I'm going to duplicate the background image. And then just to show how a straight threshold would work, we'll start with that. Under Image, Adjust, Threshold, I'm going to then threshold this image. And I can't get this, when I get finally some of these smaller particles up in here, I'm also capturing some of the edge particles that I don't want to include. So straight thresholding doesn't work on this particular image. What I'm going to do instead is under Filter, Other, High Pass, I'm going to set a high pass radius. How I set that radius depends upon the length of each one of these particles. So to start off with, I'm going to go to the eyedropper tool, choose the ruler tool, and then measure the distance of one of these particles, the largest particle. And then over in my info box, I'm going to see what that length is. And it shows that it's 120. So under Filter, High Pass, I'm going to set the radius. I'm just going to set it at 100. Now, using my keyboard command, I'm going to bring up the threshold tool, and I'm going to set it so that I see only the larger particles, and those are thresholded. To get the smaller particles, I'm going to again duplicate my background in the Layers palette, and then click on the eye icon to turn off the background or the layer that's above the layer that I'm interested in. And then under Filter, High Pass, I'm going to presume that those particles are sitting probably at about 10 pixels. I'll put in 10 for the radius. And then again, I'll threshold. And this time you can see I'm capturing many of the smaller particles. Those particles are actually way too many. I'm going to minimize that somewhat. If I zoom in, I can see that I'm capturing some of these particles. I think I want to capture a few more. If I say OK and zoom back out, now you can see that there are a fair number of particles that are sitting in this solution that would not have been thresholded easily were I to use only the threshold command. And then just to get all of the particles, I'll again copy the background layer in my Layers palette. And this time I'll put in a nominal value of 50. And threshold one more time. And that'll get mid-sized particles. Now to put all of these together, under background copy the top layer, I can choose the drop-down layer mode and choose darken, and then go to the next layer and choose darken again. And then I can flatten the image under layer, flatten the image. And this is the image I can then measure. Here is a rather difficult image. This is of retina, and you can see that there's vessels. First of all, I'm going to determine what the minimum width would be of one of these vessels that I would like to threshold. So I'll zoom in, and you can see that it's less than 2 pixels in length. And so that means I need to be able to enlarge this image in order to get at least 8 pixels. Under image size, make sure that resample is chosen, click bilinear, and make the width 400%. Now when I measure that same width, I'm going to get something a little better. Here it says that it's a length of 10 pixels. So I'll start in the layers box by duplicating the background. And then under filter, other, high pass, I'll set the radius at 10 since that's what we measured earlier. Now I'm going to zoom in so that we can just look at one specific area while we do our threshold. So I'll go ahead and threshold the image using my shortcut key. I'll back off and then come back again to determine where I should make the setting. I'm going to go to a threshold level of 130 because that seems to collect as much of these connecting vessels as possible. The white is what I wish to measure and the black is what I don't want to measure. And then I'm going to click the eye icon on and off to see how well this thresholding worked. And I'm going to highlight a small area just to focus on this area so that we can see how well it did. If we click this on and off, it did a fairly good job of capturing that. However, what it hasn't done is it hasn't collected it at the same width. Instead, it's made the width much greater. We don't care in this instance about the width if we want to measure a length, because later we're going to reduce that width to 1 pixel. If I wanted an area, if I wanted to measure the area taken up by vessels, I could then use a couple of filters. Under filter, other, I'd start by increasing the thickness of all the vessels. Here I'm using a maximum of 3. And then I'd follow that by increasing the black part of the image. And in this instance, I'm going to use a radius of 5.5. Say OK. Then if I check, let's say this area here, if I check that, I can see that it did a fairly good job of thinning out the vessels and giving me a good estimate of the area taken up by the vessels. Okay, let's go back to length. There are some spots here that actually are a true reflection of what's happening in the image itself. If you look at that spot and that spot, you can see that those spots are cross sections of vessels. However, we're going to get rid of them in ImageJ so that we measure only vessel lengths. So I'll save this image, and remember, if you save it as a TIFF, to unclick layers and then open that image in ImageJ. As far as my reference image, I'm going to correct it for uneven illumination, and I can easily use the automated actions from Sedgewick initiatives to do that. So now I have an image that's corrected for uneven illumination. I can simply threshold this to include all of the tissue area except for the few places in which there are holes. And then I can save this for measurement in ImageJ. So I've opened up the thresholded image in ImageJ, and I've also opened up the original image, the raw image. That there are these rounder structures that could be removed and some small structures that we don't want to measure. So when I actually do an analysis of this image, I can remove those. First, under Adjust, we'd want to threshold the image. And because it's a black and white image, I simply need to move the top slider a little bit, and then I can cover the area I want to measure in red, and that's the thresholded area. Under Analyze, if I analyze particles. But before we go to analyze particles, we'd like to first of all set the scale. Be sure this scale has a unit of length that's a pixel, or put in your known distance in pixels to create your own unit of measurement. Under Analyze, if I analyze particles, I can use this classifier called circularity. A perfectly round thresholded area would be 1, and anything less than round would be closer to 0. What I want to do is exclude those parts of the image that are more round, and so I'm going to put in 0.6 as a starting point, and then we'll see what happens when we show masks from this drop down. I don't need to show the results or anything, so I'm just going to say OK. And you can see right now that it did a fairly good job of removing the circular areas and really left only the areas that are vessels. I'm going to use the mask image that has the vessel areas. Of course, it contains this border here, so I'd want to get rid of that border. I'd want to use the magic wand tool, click inside that area, and then under Edit, Fill. Be sure when you use Edit Fill that under Options, your colors are, the foreground color is white. And then I could do the same with this area here, Edit, Fill, and these small areas here. If I hold down the Shift key, I can choose more than one. Edit, Fill. Now I have an image which I can skeletonize, and that will get me the lengths of all these vessels. So under Process, the first thing I want to do is make this into a binary image. Again, under Threshold, I'll threshold the image. And then I'm going to duplicate this image just in case I make a mistake and I need to have this image again. So I'll put that to the side. Now what I'd like to do under Process, Binary, Skeletonize it. Now if I zoom in on this image, you can see that all the vessels have been made into single pixel lines, and that every branch point here you see coming out of these lines is believed to be a branch point of each one of the vessels. Actually, this shows way too many branch points, and so the image was a little too complex. So what I'm going to do so that it isn't so complex is I'll go back to the duplicate image, and from this image I'm going to make it less complex. So I'm going to zoom in here, and then under Process, Filters, I'm going to use a median filter. And I'm going to use this median filter basically to blob the image a little more so that it isn't nearly as complex. I'm using a radius of 8 to make that happen. Now there are these smaller dots that I will want to get rid of once I do this. I say OK. Now I need to threshold the image again. And this time under Analyze, Analyze Particles, I want to get rid of the smaller, the smaller blobs. And so I'm going to go from 200 pixels to infinity and see what I get. And in this image, the rounder blobs are gone. So now under Process, I can again make this a binary image. Again, I can go over here and threshold it. And then under Process, Skeletonize. And here you'll find an image that's far less complex. Now under Analyze, Skeleton, use Analyze Skeleton. And here we're just going to show detailed info. Nothing else is going to be checked. I'm simply going to click OK. We have then results, which I don't tend to use. Instead, I use the branch information. From this branch length, we can get a sum. We can determine the total length of vessels that are in this image. So I'll save this as a CSV file. For the reference image, I'm going to get the area. Under Analyze, I'll set measurements so that I can include the area. And that's really all I need for this. I'm going to limit it to the threshold and display the label. Again, under Adjust, Threshold, make sure that red covers the part of the image that you want to measure. And then under Analyze, I could simply use Measure, and that will give me the area in pixels squared. Once we know what we're doing to an image, we can then create an action. So I'm going to bring out my Actions box here and open it. And then here you can see that there are Sedgewick Initiative actions, and we're going to unclick this button mode so that we can then see the actions, the text that show what the actions are and what they do. And click the chevron buttons and start by creating a new set. And we'll just call that Quant. And then start creating a new action. Let's call this Retina. So we can now start to actually, if you see down here, it's actually recording right now, and this red button at the bottom is showing. And we can go ahead and do the steps that we had done earlier. In this instance, we changed the image size to 400%. Then using the threshold for getting branching, we would then go to Filter, Other, High Pass. And then for the thresholding, we put in a value of 130. And then if you'd like, you can include an image save. But I'd rather not do that. I'd rather keep the image open and the image save separate so that you can do that for each one. Then stop the action, and now you can replay this action for other images. Just to test it on this one, I'll revert the image to what it was and then play it. And there you go. It's that fast. And this can then be applied to other images using the batch command. And in this command, you can say what set you're using, what action you're using. You can say that you want to go to a folder to open images in that folder. And then in your destination, you could say none, or you could say save and close. In this instance, because I didn't include a save function, I'm just going to say none. So that way the image will stay open and I can save it myself to wherever I want to save it to.